Testing the audio. Testing the audio.
Like 5 years, I don't know.
Okay, hope everyone gets refreshed over the weekend. This week, the lesson for this week is very important. It's about data cleaning and data summarization. These are critical steps in every data science project. And we have sufficient exercise in your assignment to practice these all these concepts in this class. So the assignment has been posted. There are 12 questions, and next Monday is the Labor Day, so I guess it's not ethical to have the due date on Monday. I'll move that due date to Tuesday. Okay, but it's only for this assignment. What's this week's assignment? All the remaining assignments in the later semester are still due on Monday. Okay. So first, so data cleaning and summarization, especially data cleaning, it's a critical step in every data project. And the summarization, and before you do any prediction model or do visualization, you have to do summarization first to get a summary of the data, to understand the data. First, let's have a brief introduction of the Pandas library. We talked about NumPy library last week. So NumPy is basically for numerical data, and it can now allow strings or other object. But most of the data we see are string, a text, right? A lot of data we see a text or date or time. So oftentimes we use a Pandas library more, and this Pandas library is for two-dimensional data structure. It's similar to the spreadsheet we see in Excel or Google Sheets, and it supports different data types. So you can have one data type, each column could be one data type, and you could have a different data type across the columns. The main differences between Pandas and NumPy. First, Pandas deal with the tabular data, like a table, and NumPy deal with numerical data. And for the object in Pandas, we call it a data frame. And for NumPy, we call them arrays. Because the Pandas address different data types, support data with different types, so it consumes more memory, and versus NumPy is more memory efficient. And indexing with Pandas is slower than NumPy. So let's just get into the library and to load some data to see how it works. And here in this lesson, I'll use this data set for demonstration. You can download it from this website, Kangol. I've included the link here, and I also included the link in the notebook. Haven't I? I'll upload the notebook soon. So here I already downloaded it in my desktop, and I uploaded the data set. No, this is the one for your assignments, but I did download it somewhere, and I uploaded here to my Jupyter notebook. You can see, and now we can read it into the Jupyter file. And we assign this to a data frame. I just call this data frame, this object data frame. So I can use this function to read this CSV file. After we reading the data, what we like to do is to get to know the data, have an overview of the data. What we usually do is to know the shape, how many rows and columns of the data frame, and what are the data types of each column. And also, we can fetch the first top 10 rows from the data set. So let's see if it's loaded. Okay, it did work, and now I can check the shape. Again, tells us it has over 30,000 rows and 292 columns. I don't think they are all useful, but it gives us sufficient data, so that's good. And then we can see the columns. It doesn't tell us all the column names because it has too many. Sometimes in such a case, we can add this function to list, and it will show all the columns. We'll use it for later. And also we can get the data type. You can get the data type of each column. So as you see, some object in Pandas is like a string. And these you're familiar with, the integer and the float. And we can fetch the top 10 rows. You can use head or tail count from the bottom. And to have an overview of this data. We observe the data. This table, we see it's not a perfect data because it has a lot of null values, and I mentioned it's 292 columns. This data set is some records from a housing market, and these are the living square meter, the square meter of the whole property, and then toward the end, usually the last column usually is the target variable price of the house. And you see it has a lot of columns, and some of these I really don't know what these big church count. whether it has church in the community. I don't think it's really relevant to the house, the price of the house. So what we are going to do next is to clean up the data first, to clean up the data so it gives us the table we want to predict the housing price. So it comes to data cleaning. So why data cleaning is so important? There's a classic saying in the data science field. They say garbage in, garbage out. If your data is dirty, is raw data and not cleaned, even if you have a good model, it will not produce good result. Why? Because it's not accurate. For example, if you have too many null values in a numerical column, what will happen? Like this is a price, and it has a lot of numerical. It's a numerical data type. The column is a numerical, and it has too many zeros, too many null values. What will happen? How will it affect the result? For example, if you want to get to the median, the average number of the price, what will happen if I have?
Yeah, that's just because skew the results of the averages.
That's right.
You know, all of the prices added up divided by the number of
Yes.
houses or rows in that case.
Mm-hmm.
Yeah, you can't add null to anything.
Yeah, if you have too many zeros in that column, it will bring down the average price. Affect other statistical data as well. So that's why we have to clean the data and very well first. So this is it's a pyramid for the cost of bad quality data. If you do the cleaning at the beginning of the project, only cost $1 to preventing the bad data. But if you go to the next step, like data visualization, and then you do the cleaning, you have to go back to the cleaning and run all these processes to come to reproduce the result, and it will cost probably $10. And if you go to a later stage, like prediction stage, then it will cost even more. So this is the pyramid of cost of bad quality data. It's important we minimize the cost for every project and to do the cleaning at the beginning. But come back to this data, and like I said, the first thing we want to do is probably drop some columns and some features that are not that relevant. I'll go back to this list of column names. So to do this step, you have to make sure that the column you want to drop are not relevant. I want to start just for practice. I'll just start with maybe below 25. I think it's about this area. Okay. But for a real data project, you have to make sure these are not relevant. And I'll drop starting from column, the feature number 26, and all the way to not to the end, but I want to save this target variable that's important for the data project. So I'll drop these columns. First, I'll create a list of the columns I want to drop. This is from 25 to the last column. Last column is the 20. Last column is 20 index 21 should be. I just so because this we mentioned the last week, this is start number. This number 222 is not included, right? The end number is usually not included. So we'll go from 25 to 291. And the index, let's see, is 0 to 290, 0 to 291. So we want to keep that. So we need to go from 25 to drop the column from 25 to 290, right? 290. Let's see. So let's see if this gives us the result or not. And call this remove. So in Pandas, now this is actually built-in function. There's a built-in function. This one, data frame job. Yeah, this is a Pandas. So you can just use this job function. So what we are going to operate on is this is data frame. DF is the data frame, and we are going to work on and a job, and what are the columns we want to job, and we already included in this variable. So these are the columns we want to job, and also x is equals 1. Maybe these are the other parameters we need. This is in place equals true. So this is the parameter find that if you want to replace the original source or not. Usually we keep the original source and create a new data frame for each step. In that way, you can fetch the data frame at every step if something is wrong. So here I didn't say in place equals true, okay? And let's see the columns of this. Okay. Start number, end number. Okay, it looks correct. We did keep the target variable and reduced to this number of columns. So we check the shape again. It should have 26 columns. Okay, looks much better and will work faster, more efficient. So I would think this this step should be the first step in every data cleaning project. Some of the article you read, they may do it later, or they may skip it if the data set is small. And also with this function, you can also remove a specific column instead of using the column numbers. For example, here I want to think of the hospital beds ratio on, and the hospital beds. I don't think it really affected the price, the housing price. So I want to drop this column, and you can also do this. Instead of giving it a list, this list we created, instead of giving it a list, you just give it the column name. So, no, we should jump based on, no, we should run this. As you see, we also dropped this column here. So it's good to check the shape of your current data frame every time after you do some cleaning to make sure you did the correct thing and gives you the right shape. Okay, so this current data we have with 25 columns. And the next thing I'm going to do is to deal with these null values. As we see, we have so many null values here. And let's first take a look at how many missing values we have in each column. There are two methods to check the missing value. One is to get the number of missing values in each column, and the second one is to get the percentage of the missing values. And let's see how we work on it. So. So the function we are going to use is this one is now. If I just run this one, what it will gives us is a table of Boolean, whether all the fields are null or not. So these are false. So these are null values. It's true. And now what we can do, we don't really need this table, but what we need to do is how many null values in each column. What we can do is to sum up. In this way, it will give us the total number of null values in each column. Sometimes this may not be intuitive, so I don't know what this means, because it may have a large number of it may have a large number of rows. Then really it's a small number, so it's relevant. It depends on how many rows you have, right? What we'd like to have really is to get this percentage of missing data. So what we can do is pretty the same, and we need to create a list of the columns again, this list, and then we'll go over each column and to print out the percentage. So this is let's see, this is the column, gives us this is all the list of the columns, and this gives us this iterative, and each column is this list. And so now we get each column, and we count the null values in each column. And to get the percentage, what we also need is to divide by the number of rows in this data set, right? How do we get the number of rows? We can use the shape, and the first number is the rows. So we can do is and this is shape. You see the shape returns two values, and the first one is 0. So that's the index for the first one should be 0. This gives us the number of rows. So, okay. Great. And I want to use this is the column name. So the column name, and then the percentage of missing values. Let's see if it works or not. Okay, go. Round up. Should look better. So it gives us the percentage of missing value in each column. We can see some of these are very large. Almost half of the values are missing. 45%, half of the values are missing. All others are quite good. Okay, so now after we get to know how many missing value in each column, and then we need to adjust the missing data. There are several methods to adjust the missing data. It depends on the need and depends on the characteristic of the data. Very depends on your needs. For example, for the first one is to drop the features that have a high percentage of missing data. I'll come back to this. When we come back to this list. So for these, it has a high number, but can we really drop them, like building year, the year the house is built? I do think it really affects the housing price, right? Even it has a high number of missing values, I don't really want to drop it. But for these preschool quarter or school quarter, maybe I could drop them. So I could use this first method, dropping the features with too many missing values. Okay. The code, we already showed the code in the last slide, how to drop the features, right? So you can do this. And the second method is drop rows with missing values. For example, here, I'll say build year, the year that the house is built. I do think it's really important to the housing price, and I don't want the missing values to affect my result. So I want to drop all the rows with the missing values. Or what we can do is to use this feature, drop null value. And I have posted here this the structure of this function, the parameters. When we want to try a new function, what we can do is to look up and to go to the pandas. We see there are several parameters. Axis is usually 0 because we want to drop the rows, and how is that there are two options for how. Any means if any data in the row across the column is if there's one missing value, then this row will be dropped. Or means if all the values are missing, it will be dropped. I think or is often used. Any maybe this option may be used more often. Slash means if some of the values are missing. For example, if it has more than 5 missing values, then I'm going to drop that row. Okay. Subset means one of subset means one of the column. If one of the column has missing data, you will drop it. So it really gives you all the options. If you want to drop all, if you want to the row have, if you want all the columns to meet the condition, or just a couple of the columns to meet the condition. So, for example, here. With this with this data set, I can set up if the data set has more than the data frame has more than 5 missing values, I'm going to drop that row. Okay, I'm going to drop that instant. So what we can do is to use this function, and the axis is 0, and I can use this parameter slash, and it's a little bit tricky here. So this parameter slash, it really doesn't ask you how many missing values you want in each column. So for example, I want to have maybe if it has more than 5 missing values, I will drop it. But it really doesn't ask you to input 5. Instead, you have to input the non-null values in this row. So here I have how many columns we have now? I think 25, right? 25 columns. So yeah, if I wanted to have less than more than five missing values, then it means that the threshold, the thresh is 25 minus 5. So it has more than 20 values in this row. Okay, so it's a bit tricky here. Let's see if it works or not. So there's a new data frame. I'm going to name it this missing value. And after we do this step, let's check the shape to see if it worked. Okay, it did work. It had over 30,000 rows, and now it only have 20,000 rows. So this to drop the rows that has too many more than 5 missing values. Next, I'm going to do is using the subset, like this build year. Just mentioned that I think this is really important for the housing price, and I want to drop all the rows that has no build year. So what I can do is to use this parameter subset. Let you specify the condition to one or two multiple columns. Here, I can do. And I'll use this job now value function again. Instead of define this, specify this number, I use another parameter that is subset. Because what is the variable build year, right? Build year. So I use this variable. And now it's going to drop all the rows that has no build year. Okay, let's check the shape. Okay, it did work. Dropped like 5,000 rows. So this is how we deal with the missing value. And there's another method. When you really don't have that many instances in this data, I don't want to keep the instances, the rows. So for example here, this number of room. Okay, we'll use this feature number of room. It has it doesn't have a missing value to offer, but we can use a frequent number to replace the missing values. Usually the number of rooms are 2 or 3, right? So in such case, if we don't want to drop this feature, you can use this frequent number to replace the missing values. This is often an often used approach also. So first, let's get the number, whether this number of room is usually 2 or 3. I'm not sure. And let's get to the median number of this this column. So it will be column and the median. Okay, so here for this market, the most frequent number for number of room is 2. So we'll use this to replace the missing values. And here we are going to introduce another function here, filling missing number. Okay, filling now value. We are going to do is to fill the missing value. And there are 2 parameters. So one is the number, what is the value you're going to be replaced with. There's a number we are going to replace the now values. And again, in place. So whether you want to operate on the original table or not. I just said that we don't want to work on the original source, so we can easily get the data frame if we did wrong at any step. So I just rename it. Okay, let's try this first and to see to check the result. Let's try this first and to see if it worked or not. Okay, it did work, and if we check this again and to see how many null values do we have. Okay, it did work. So you don't have to reassign the data frame actually. Okay. So this data changes the original source. We don't have to reassign this to another data frame. That's convenient. Okay. These are the three methods we used to deal with the missing values. Okay. Next one is removing the duplicates. Usually, a data frame should have an identifier, and you can use this identifier to remove the duplicate. So, for example, here the identifier should be the first column ID, and it could have duplicates. And let's see if it has duplicates or not. Okay, how we are going to check is to we use this drop duplicates function to drop if there's any duplicates, we are going to drop it, and we can compare the shape before we drop the duplicate and after we drop the duplicates, and to see if there were any. Right. Here are two parameters. Subset allows you to define what will be the key, or what would be the key you want to use for determining whether they are duplicates or not. It could be the identifier, or it could be multiple columns. And this is the key. When there are duplicates, do you want to keep the first row or the last row? So this is the key, this feature. In your assignment, it doesn't have an ID. The data set you use in your assignment, it doesn't have an ID. But look at this data. This is a data frame with all the classes on the course, all the courses are on Coursera. Sorry, this happens again. Just have to be patient. There. So if you look at your assignments, the data set, all the courses, it doesn't have an ID number, but what it should be unique is the link to the course, right? Each course should be associated with a unique link. So you could use this as an identifier. Okay, we are back. So this is the job duplicates function. Okay. Let's try this. Set. And I'll keep the last. You could choose first also. And then let's check the shape of the data frame before we drop the duplicates and after we drop the duplicates. Okay, so we see it returns us the exact same numbers, so which means that it didn't have any duplicates. It didn't drop any duplicates. Okay, so this is the third step, removing duplicates. The next one is fix some structure errors. Sometimes the feature, it looks the right data, but it has the wrong data type. So what we call it structure errors. And here you have to be especially careful of the dates or times, those columns, those features. Okay. For example, here, let's go back to look at the columns. And do you have any date? Yes, we have the build year. We have the build year here. This is a date, and this is also a date. And let's check the data type of these features. Okay. We actually did check it. We can go back to. It doesn't show here. Okay, I just check it again. So this is a float number, okay, 1980, 1990 float number. That sounds correct. It could be an integer or it could be a float number. I think it doesn't matter, but it's a number, so that's good. Let's check the date type of the other feature, timestamp. Timestamp. So this data type is an object. O means object. Object in Pandas data frame is like a string. If it's a string, can we retrieve like how many houses are sold in spring, or how many houses sold in January? We cannot do these operations, right? So what we need to do is to change this to a date time data type. there's a function here. We are going to introduce a new function here to data type. That's what we are going to use to change the data type. And first we tell it which column we are going to change. And then we have to specify the format we are going to have. Here the format is the format is the year, month, and date. So okay. So pay attention to this format. So you have to specify this year, and this month should be non-capitalized, and also the date should not be capitalized. Lowercase. Sure. And then we reassign this. This changes this column to date time, and then we have to reassign this value to the column. Okay, it works. Now, after we change this to date time, now we can extract the year, month, and the date. So we can create a new column called year. And I just use this column, and to get this is to use this attribute, and then it will give us the year information from this column. Okay, and same, we can use this to extract months. So later we can know how many months or how many houses are sold in that month. And now if I run this, run another code, I can get the number of houses that are sold in each year or each column. So you can see this gives us the overview how many houses are sold in each month. Okay, so this is to transform the data type of the dates. It's not responding again. Another thing we want to be we want to check is the categorical features. Categorical features are like like here. Here, like the typical categorical feature is a product type. Product type, here, this means whether it's an investment property or owner occupied property, like home residential, no, whether it's a rental property or a homeowner occupied property. So this product type should be some only a few values, right? It should be limited to a few values instead of have a list of a long list of values. So let's check, see if it's correct. Again, we can do this one. So it looks correct. It only has two options: investment or owner occupied property. If it has an investment and then another investment with I is lowercase, then it should be corrected because those should be the same type. Right? Or sometimes the owner occupy this. Someone make the import. It might import like an underscore between these words, and then have a third type. Then this is not correct, and it should be merged. Right? And here, let's check another. Check the sub area. This could be sub area, the cities or the district of the property. So it could also be a categorical feature. Let's check this one. So this returns 146 unique values. And look at these are quite good also. But if there are some values, this maybe this one, like if there's a second value that's not capitalized, then it will give you two lines. Then you have to transform this to lowercase. Here I provided the code. If you want to transfer it to a lowercase, then you could use this function, okay? And then you can count the values again to see if it's gone or not. So after you merge the lines, there should be a less values, less options for that feature. This feature looks good, so the options here looks good. I'm not going to work on this. And the last one we want to check is numerical outliers. Sometimes it could come, maybe someone typed in the wrong number, or maybe it doesn't have an outlier. So if we look at the assignment we have, for the ratings is supposed to be from 0 to 5. So even if there's a 5.1, it's an outlier, right? So the first method is you observe the data and decide with your experience. And the second method is you can use a box plot to check the data, especially if it has many instances. So let's check the box plot of this data. We'll use this living square meter. Okay, we use this living square meter. So just tell it to the column. Should give you the box plot. Start this app again. Okay, let's come back to this box plot, and if you can see, observe the data, see most all the other houses, its value, no, it's a square meter. Living room square meter is under 1,000, and only one is over 7,000. Or definitely, I'm definitely sure it's an outlier. So what we can do is to use the Boolean indexing to drop it. Here, the condition I want to use is what should be the condition I want to use? It should be living room square meter larger than 1,000. Right? So this is the condition. And remember, we need to reassign the number. We need to reassign this again. If we just do this and run this box plot, I believe it should still be there. You see, this outlier is still there, so we need to reassign this. We assign this and then we run this again. Looks there's something wrong. Let's check this code. So this gives us the row that okay, it should be smaller than this number. So obviously I'm wrong. It should be smaller than this number. That's the outlier we want to remove. So it should be smaller than this number. And so I probably have to run all these code. As I didn't assign this. I didn't create a new data frame after operating this. So what I have to do is to go back to find the correct data frame. So that costs a lot. So what we should do is to reassign this at every step. So here I have to start from this one to remove the duplicates, and then see. Okay, we recovered the data, and now I have to here after removing the outlier. See, this looks much better. There are some outliers. I wouldn't define this as an outlier. It might be just a mention here. Okay, so this is the last step in data cleaning. And remember, even it's really you check every step in these 6 steps. Okay, sometimes it may have no outlier, but you have to check all of them, all of these steps. Okay, so we'll stop here today, and next class on Wednesday we'll talk about data summarization. We should have covered most of the questions in the assignments, and you can start the assignments.